Okay, thank you for having me here again. This is another room, but I hope it will fit fine. This is a totally different talk than the one I did this morning. I'm not sure if you've been there this morning. This is actually a talk about requirements and how requirements can be implemented all the way through even tested code. And in my experience, I've seen that, especially when you do agile projects, which I've been doing for about 15 years now, requirements aren't always that solid or that fixed, and they shouldn't be, of course. So a big question in a lot of projects is, how do we get from the requirements and the business requirements to, let's say, to do some design and to do some coding and to do some testing? And you know, that particular path through your project is not always as straightforward as it seems to be. So what I will show you this afternoon, and there will be a lot of code examples too in the slides, so I hope you can all see them in the back. I hope the font is large enough. I will show you a path through all the way from business requirements, from what the customers actually want you to do, onto an application that has actually been built and been tested, and the techniques we use for that. Basically, we use a requirements technique which we have called smart use cases, and they're called smart use cases as they are a sort of extension to traditional use cases, making use cases much more usable, so to speak, in projects. And they originated from an agile approach which is called SMART. That's why they are called smart use cases. So a very, very quick introduction of myself then. My name is Sander Hoogendoorn, which is in English a lousy name to pronounce. In Dutch too, by the way. And I'm a principal technology officer at Capgemini. Actually, that's a sort of like honorary role. I don't really have any responsibilities whatsoever. I travel around the world and do some talks, and actually I write a lot of code too. When I get back to the Netherlands on Monday or Tuesday, I will be writing code again, just in my normal project. Actually, I had something to celebrate because the project, which is an agile project that we have run for 2 years now, went into production last week. That's the first production cycle we have, and we will have 3 more until next year. So I wrote some stuff and blah, blah, blah. So this is my personal website. This is actually the website, smartusecase.com, where you will be able to find much more information on these smart use cases. And this is my Twitter account. So there we go. Oh yeah, and I'm doing some more talks here as well, but you can find that in the agenda, so I won't delve into that as well. So these are the subjects for this particular talk. I'm going to have a look at different requirements technique, especially the ones we try to use in agile projects. And I'll delve a bit into how we model these smart use cases, because it's slightly different if you're used to use cases. It's slightly different from using traditional use cases, and I'll show you the differences as well. And then we slowly go into technology, as I will discuss an architecture, just a software architecture. It's actually the same I used this morning as an example, that is based around these smart use cases, where the smart use cases, which describe the behavior of your system, actually have a leading role in your code as well. And I'll show you some patterns that we use for doing that, and I'll even show you how we unit test these use cases as well. As an example, in my current project, there's over 300 of these smart use cases that we have, and we have implemented, in the meantime, I think around 200. And there's around just over 1,000 unit tests running on the smart use cases, keeping our system stable as we add on more functionality. So about requirement techniques. Now, I've been doing agile projects for quite a while, and at this point in time, Scrum is by far the most popular agile approach around the world. And Scrum is a very good agile approach. So there's a lot more agile approaches, by the way, but Scrum is a very good one, the most popular, and it uses a requirements technique that is called user stories. Have you ever seen a user story before? I'll show you some. These are in Dutch, but I have an English example as well. User stories usually have a form as a person, as a someone, I want to do this or this or that, so that I can whatever I want to do. So in this particular example, I hope it's readable in the back, probably not, but as a non-administrative user, I can modify my own schedules, but not the schedules of other users. And actually, if you look at agile projects, there's a whole lot of projects out there around the world, I see them everywhere, that use this particular requirements technique. And it's good if you build simple things. But as you will see, that user stories, there's not much more to it. you will see that in the coming years, people will start adding formats and templates for doing user stories, but there's no such thing yet. So this is it. So as a software developer in a project that has user stories, I'm pretty stuck up. Because if I have to build this as an administrative user, I can modify my own schedules, but not schedule. I don't really know what to build. It's not concrete enough. So it's too loose, and it's hardly unstructured. Now, I know that in agile projects, people say, "Oh, wait, structured, that's not our thing." But you know, if you're in more complex projects, and I'll show you an example in a second, if you're in more complex projects, then having some structure in your agile projects isn't bad. It's actually quite good. Although you shouldn't fall into a waterfall style of project, though. This is a great example. This is actually the systems landscape of one of my clients in the Netherlands, and it's actually only the system landscape of their customer services. This is a large client, this is a large company, and every rectangle in this picture is a system. So alone in this picture are about 30 to 40 different systems all collaborating. So for instance, they have subscriptions, and if I want to upload my picture for my new subscription, it actually goes to a stream, and it runs through about 12 different systems. So what they are doing is setting up this service-oriented architecture, which I will discuss on, I don't know, tomorrow, I guess. Oh no, it's on Thursday. I'll delve more into service-oriented architectures. And so they can cut a whole lot of these lines between these systems. That's what service-oriented architectures are used for. But if I come up with a user story, such as the one previously, being able to build software for this particular landscape in this service-oriented architecture might just not be sufficient. To give you an example of the size of this landscape, here is this little pink rectangle. You think all these systems are alike, but they aren't. This is SAP CRM. Now, I don't know if you have any experience in SAP, but when we started working at this client, we had a look at the size of the database underneath this system. And in this particular implementation at this client, the database underneath here had 142,000 tables. Just to give you an idea of the size of this landscape, it's big. It's actually huge. So in that case, user stories might not be sufficient to run your project in. So then there's the traditional use case. I'm very sorry that this is in Dutch, although this is a use case by a large international bank. And this particular use case, I've used a lot in, I don't have any great English examples, so if you have them, please send me by email. But this particular use case, it has a document of over 65 pages. That's one use case. 65 pages, there's a scenario, the basic scenario stretches out over 12 different pages. There's over 100 alternative scenarios in there. There's 12 different web pages in this system, in this particular use case. So this one is very hard to build. And especially if you're a tester in a project, which you're probably all not, but there's a lot of testers out there. And what testers do is they go through all the scenarios that you can run your use case or whatever requirements techniques you have. You can run through all these scenarios, and they write test cases for all of these scenarios. Now, if there's over 100 alternative flows in this particular use case, that means that you will at least have 100 square number of scenarios. So for a tester, this is hell. For a developer, by the way, I've seen the developers on this project, they got gray hairs within 2 years. Actually, the project failed. So I call this a huge case. So huge cases are not a very good requirements technique, especially in an agile project. In this particular project, implementing this simple use case, which is out here, took them 5 months. Now, if you work in 2-week iterations, like I usually do in projects, you want to wrap up multiple work items during one iteration, not one that stretches over 5 months. So that's a totally different ballgame. So then we said, well, there might be something in between there, in between these very unstructured and simple user stories and these very complex use cases. And that's what we came up with, a modeling technique that we now call smart use cases. And we actually derived it from a book by a guy called Alistair Coburn, who wrote a book which is called Writing Effective Use Cases. And it's actually not about modeling use cases, but it's about writing use cases. And he said, well, there's actually different levels of use cases in your system. You could start off with saying, oh, these are my very high-level goals, and these will probably be my business processes. Of actually, that's our interpretation of what he wrote. And the usual use case sits at what he calls C-level. And C-level use cases, they actually implement a specific user goal. Actually, the use case I had on the previous slide, the name for that use case is change address. And change address takes 65 pages in that particular bank. So that's quite a lot. So then we said, so what's at the next level? Well, at the next level, which Alistair calls fish level, there's things called sub-function level use cases. So what are these sub-function level use cases? We wondered about, 10 years ago. And it appeared that use cases at this level are use cases as well. It's just that they don't implement a user goal, they help implementing a user goal. That's our definition, sort of what we do. So then we said, if we have the use cases at this level, which are the regular traditional use cases, we can model them down one level deeper. And by doing so, we end up with a whole bunch more use cases, and I'll show you some models in a few minutes. There's more and more use cases than you would traditionally have, but they're all a lot smaller. And actually, due to the guidelines we, over the years, developed for modeling these smart use cases, we've seen that they're sort of like equally sized, which means that you can much better estimate them and you can implement them much better in iterations, because in a normal project you would do around, well, I can tell you the numbers from my own project. We do about 25 smart use case points per iteration, which is usually around 5 to 6 different use cases per iteration with a not that big team. It's a team of about 5-6 people. So this is a unit of work that is actually doable. So I'll show you what it looks like. So this is a traditional use case. You probably won't be able to read this in the back. It's a page from the Smart Use Case website as well. So this is a use case, a traditional user goal use case called register call. So if you're building a call center application, this will probably be one of your use cases, isn't it? So the customer phones and says, okay, my washing machine broke down, could you help me out? And the first question you ask is, okay, who are you anyway? And do you have a contract? And what's the serial number for the machine that you have? And what's the product you have? And what's the next step to take? So you can write that all down, ending up with probably even more than 65 pages of text for this single use case. But if you model them down one level deeper, you will end up with a model similar to this one. I'm not saying you will end up exactly the same one, but similar. So this model says, okay, if I register a call, I first need to find the customer. So here's a use case called search customer. And if this customer is not in the system, then we need to create a new customer, which is handled by this particular use case called manage customer. It should have actually been called create customer, but anyway, it's a model from a long time ago. And when I'm done with that, I'm trying to find whether there has been a previous call about the same subject and the same washing machine or whatsoever. So I'm going to do a search on call. And calls are actually calls people do. So once I've done that, and I need to identify the product that the customer has, and I need to define my first activity. So my mechanic will go, or we'll call him back, or whatever we do. So this is actually implementing the same user goal level use case as this model, except that here we would have a lot of text with a lot of alternative flows and a lot of exceptions and stuff that you might have, a lot of forms to go with it. And here, actually, we have a whole bunch of these smaller use cases. Now, there's some good things about these smart use cases, as we call them, is that, first of all, I'm a developer. And one of the things I always say is that developers don't read text. We don't read requirements. We look at pictures. Do we? Yeah, okay, cool. Glad you agree. So, developers are very visual people, and that's a good thing. So we look at pictures. So having a picture of some of these ovals is much better than having 65 pages of text for us. For developers, for testers, it's the same, by the way. And also, if you look at the size of these different smart use cases, they're more or less always the same. Instead of that, if you have user goal level use cases, one could be really complex and hard to implement, like the change address that I had earlier. But in the same project, there could be a use case called login, which is far easier. So they're not on the same scale. And with modeling smart use cases, you can be on the same scale with all your use cases, which means they're much easier to estimate. and given the fact that the law of large numbers also applies, that you can actually estimate them really reliable without knowing so much about them. Because the granularity of the smart use cases, they're all similar sized and they're all small. So that means that the law of large numbers starts to apply to your estimation. Actually, law of large numbers sort of says, like, if you have 100 things to estimate, there's probably be one that you estimate too low, because it appears to be much more complex than you think it is. But on the other hand, if you have 100 items to estimate, there's probably also one that you estimate too high. So that levels out. So if you have enough items to estimate, in this case smart use cases, your estimate will become much more accurate. That's the reason behind this. So in Agile project, it's also a very good unit of work, because you can implement a number of them during each of your iterations. And then again, the funny thing is that we discover that if we model them one level deeper, and I'll go back one slide for that, reuse becomes normal. In this particular use case, with a whole lot of text, you cannot see the reuse. There's no function. What to do is get them to be traceable into the code. And that's where it starts to be interesting for developers and also for testers. And they're also much better testers, because there's only a few alternative flows in these use cases. So how does it work? Let me show you a bit about it. This is just an example. This is, by the way, a rather complex one. Most of these diagrams, use case diagrams, are much easier and much smaller. But this one comes from a very complex project with a lot of back-end systems and a lot of workflow in there as well. So this is just an example. As you can see, it's also a working document. People spill coffee over it, people write on it, and they put it on the wall, and it's a very good unit of work for me. So basically, we start looking at what would be a decent approach if we look at the desires and the business requirements from the business people and the customers and the stakeholders and whoever's involved in the project. So what do they actually want? Well, usually that sits at a very high level. It's usually something like, yeah, we need something to keep track of our customers and the appointments we make with them. And of course, you all think, oh, that's a CMS system. But usually people don't think in systems when they're in business. They say, okay, I need to be able to see which customer I visited over the last 3 weeks. Stuff like that. That is requirements for them. So you can look at the business scope and you can identify from that. And you know, I also do training courses about this subject. And this particular slide I can actually talk about, well, at least for an hour, I guess. But I don't have time enough to do that. So this is the very brief summary to that. So we say, you know what? Split the scope of your project, which is the thing you start with, up into the business processes that you try to support. There's no IT yet in here. It's just business requirements. And the good thing is, if you talk to your customers directly, then they'll be able to speed up everything that's in there. And it's a very simple technique that you can do. I'll show you some examples in a second. And then we say, well, usually there's two types of these processes. It's actually either a cluster of processes that are independent but sort of relate together, like everything to do with authorization, for instance. Like you could have log in, log out, change password, change authorization, stuff like that. Things that go together but act independently. And here's your larger process that usually has some workflow in them. Like book the tickets, book my trip to India, for instance. So it involves booking four plane tickets, booking a hotel, see that there's a taxi from the airport, stuff like that. So there's a lot of steps involved. And this is, I usually call that a chronological process. And if you're into business process modeling, which you're probably all not, neither am I, but I've read some stuff about it and I've seen it in projects. Actually what happens, if you look at business process modeling, they usually end up modeling up to a level where each of the elements in such a diagram is called an elementary business process. And it's usually these are recognizable because there's a guideline that's called AutoPOP, which says one time, one place, one person. So if a process is executed at one time by one place by one person, it's usually an elementary business process. And that's a good step up for going to software development. You see, this is all still analysis, business requirements, business analysis, information analysis. And this is where we slowly go into the technology. Because what you can do, we find out that each elementary business process in a business model actually sort of like is similar to a user goal level use case. So here's the ovals that end up being huge cases. So you try to identify them directly from those. So each of these little squares at this level becomes a smart use case, becomes a user goal level use case. And then the next step, which is the most fascinating step, I think, is going from this one use case with a whole lot of text in it, well, actually not writing it down, but splitting it up before writing it down into a model that has more use cases. So I'll give you an example. And the example would be, this also comes from a very large Dutch company, so it's in Dutch, the example. This is the hierarchy that you see at the left side of the previous slide. So this is the scope for my whole project, and these are actually the business processes that this project tries to implement, given this particular complex landscape that they have. So if you drill down, for instance, to this one, which is called managing customers, actually, that's sort of like the free translation in English. I could delve down, and I'm in this. So this particular diagram, it's sort of like a chronological process that actually implements this particular rectangle here. So now we're at kite level, as Alistair Cockburn calls it. And we can go one level deeper. And I will take this one as an example. It's sort of like, well, let's call it prepare bills, something like that. So it's actually back-end functionality that sort of like puts everything together so the bills can be sent out and that kind of stuff. So this is the step where we say, you know, this thing is actually an elementary business process because it takes place in one location. It's actually by one system, actually. It's not a person, and at one point in time. So we can go on to use cases. So this particular thing called prepare bills will actually be modeled out into a smart use case diagram, where this oval actually represents the rectangle on the previous slide, and these other use cases around it are our smart use cases. Actually, the whole bunch is the smart use cases, but these are the sub-functional level use cases. And the funny thing is about this thing is, although we're talking about web application development now, these particular use cases in this diagram are all implemented in SAP R3. So they also can use this particular unit of work. So there you are. So how do you get from this one big use case to a whole bunch of these use cases? So over the years, just from being in projects, we established a list of guidelines to help you out to find out these smaller use cases. And actually, it's not a final list because it sort of like grows. There's new stuff coming to the list. As an example, we say, well, if you think that an element of this bigger use case can be reused over and over again, like the search customer use case I mentioned earlier, just pull it out. Make it a separate use case. And the same thing goes, and that's an interesting one if you build web applications, is that we say usually or normally, or it's not a rule, it's a rule of thumb, we say that don't try to handle more than one form in a use case. So it's not that the form is the use case or the web page is the use case. There's a use case executing behavior, and there's a web page that goes along with the use case. So that's it's sort of like different view on that. So we also say if there's a form, so not a message box saying yes, no, cancel, but an actual form that has functionality, pull the use case out. So that, again, that will be a reason to pull out search customer because it has its own screen. If you're building, let's say, SharePoint sites, what a lot of people do, you will have web parts. Web parts usually have independent functionality of the other web parts that are on the same portal page. So we also say if you do that, please pull out the web parts as separate use cases as well. So there's other stuff. So like complex calculations, like I was working at a pension fund and they had, I don't know the domain. It's a very complicated domain, at least in the Netherlands. I don't know what it's here in India, but we have very complex pension rules. And so we had to calculate pre-pension before I got in the project. I didn't even know what it was. And it appeared that I was actually saving for it. I didn't know, out of my salary. So, but calculating pre-pension, we didn't know what it was, but it sounded complex, doesn't it? So we said, okay, we'll pull it out as a separate use case. So we built that one separately. And the same goes for reports and if you interact with other systems, et cetera, et cetera. So these are sort of like the guidelines of getting from this one larger use case to a whole bunch of smaller use cases. And this is just another example from an online dating site, actually, where you can apply for membership and you need to enter your membership data. It gets validated. We enter the credit card data. That gets validated against the credit card company. This is actually a simplified representation of it for training courses. And we send out a confirmation, etc., etc. And then later on, you have to activate your membership, which comes with a web page that you need to go to, and you're required to change your password. This is actually what this model is saying. And as you can see, as I read this model, it's very easy to read these smart use case models. You can just, it's a good way of communicating with your clients as well. So here's another example of a project that printed them out and hang them on the wall and draw other pictures on it, and it changed a lot, and et cetera, et cetera. So it's a nice way of working in projects. So here's the other one. I already discussed this one before, so I won't do that now. And the last step is, you might think, oh, where's my design? People are used to writing text. Well, usually a use case is a piece of text. And it consists always of the same parts. You describe the actors and the goals. So who's executing the use case to get benefit from it? That's called the actor. And what are the goals for doing this use case? So in this example, it's a use case called create driver. And the goal is to, well, probably to create a driver. That's pretty straightforward. Looks like Microsoft documentation. If you have a function called open file, then the documentation will be call this function to open the file. It's like they generate their documentation. Again, as I said this morning, I love Microsoft though. So use case has pre and post conditions. Well, the preconditions is the stuff that it's sort of like the contract you have with the use case. If you're able to supply the preconditions to the use case, then the use case will do some work for you, resulting in what the post conditions are of this use case. Right? So that's the way you describe use case. And then it has a basic flow. All use cases have that. It's a number of steps that are taken either by one of the actors or by the system to implement the work ending up in the post conditions. And the last thing that you write in a use case is that there's alternative flows, which you cannot see because they're down there, but these are the exceptions to the basic flow, or exceptions to other exceptions, and that's why it gets complicated. So usually, if you write a traditional use case, the 65-page document, it has alternative flows to the basic flow, and it has alternative flows to an alternative flows to that alternative flow, and it can go deeper and deeper and deeper. If you make the use cases smaller, like the smart use cases, you will see that the actual documents that you will produce for a use case, if you do that at all, because we standardize them a lot, so we don't always write the documentation, you will see that you will have only a few alternative flows, which makes it much easier to develop and much easier to test. So here's what you see, what can come out of tests and test scenarios, and I'll skip that a bit. So the last thing before we go into a bit of more technology is that over the years we found out that there's sort of like standard types of smart use cases. Like I said, if I need to search a customer, that's probably a use case that has a web page that you can identify some criteria, and you can press the search button, and there's a list of, and you can pick one or say cancel. So that's typically a functionality that you will see in a lot of applications. So we've identified a lot of these standard types of smart use cases. And if you follow the UML, the Unified Modeling Language, you would call that a stereotype. That's what it's called. And if you model them in UML, then you would see that it will end up here. So for instance, you could say, well, this is a master detail on product and order. This is typically, and the funny thing is, if you go into these projects, you will see that actually using these stereotypes becomes the standard vocabulary for your project. So people actually talk about, hey, we have a service that aggregates customers and orders, or we need a search for a product, or we need a search for office, or we need a manage office, stuff like that. And it becomes your basic vocabulary in your project. And the good thing about it is that you need to document less. And again, we also, as Capgemini also has large offices here in Bangalore, for instance. If we do distributed projects with teams that are co-located, for instance, in the Netherlands and in India or in other countries as well, is that this makes a much better way of communicating between analysts and developers about the functionality that you need to build. So that's a good thing. So we've added a list to the website. This is actually another page from the smartusecase.com website, where there's a whole bunch of them. And this website is actually a wiki. So if you start using this stuff and you find more of these standard types of smart use cases, don't hesitate to add them to the list, because that would be great. So slowly into technology. Here you see a use case diagram, which is actually coming from my current project. So this is an actual example. And it says, so there's a lot of master details in there. There's a select, which is just a list of stuff. There's a search and views, and so you name all of them. And we also use colors to identify different types of smart use cases. So then into the technology. So here's an architecture. It's a very basic architecture. I've displayed this one this morning as well. And it actually says there's 4 layers, but you can have more if you want to. I wouldn't know which ones, but so there's a presentation layer with your web pages, and there's a domain layer. I usually have domain layers in every of my projects, and there's a layer that sits in between, for instance, the database and your domain layer. So it's called the data and services layer because you could also have services here or web services or whatever you might want to use that gets the data into your system. And there's one layer in between, which is not a usual layer if you look at web applications. Most people skip this one. Why? Well, because most web applications are just pages referring to each other. And that's something that we don't do. We say, well, the behavior is already modeled in these use cases. So what if we add a layer in between the presentation and the domain layer that handles all process? It handles the workflow. And we've already modeled them. So what we actually do is we implement the exact use cases in the model in code. And that's what I will try to show you. So this is actually, if you look at the Solution Explorer in Visual Studio, I tried opening up Visual Studio, but oh, my mouse is not here. So I'll use the code in the slides. Otherwise, I have to browse through a lot of code to show you all the stuff. So what you actually see is that the application picture, architecture picture that I just shown you, is also reflected in the code. So there's a business layer, and it has my domain objects, and it has my factories, my enumerations, my search objects, etc., etc. There's the data layer that has gateways, and it has describers, sort of like mapping files. And here's my process layer. And in this process layer sit all my use cases. I'll actually delve into a bit of code just to show you these use cases. Now I have to, oh dear, oh no, I'm not going to do this because Visual Studio crashed on me just when I was sitting here during the previous talk. So I'd probably not be up and running for the end of this talk. So you can actually implement that. How do you implement it? Well, we use something that we call the task pattern. And actually what you will see is that a typical smart use case runs through all of the application layers. So for instance, if I'm going to search a customer, I'm going to start the use case. The use case says, hey, what am I? I'm a search customer use case, which means I first show the web page that I can put in some criteria, and then the user types in some criteria, presses the search, goes back to the use case, which acts as a controller, so it handles the request for searching for customers, goes back into the domain layer, talks to a factor or a repository and says, hey, give me all the customers that meet these criteria. And so the repository goes down there, goes eventually in the database or over the web or whatever it does, comes back with a list of customers, and the use case says, okay, web page, here's your customers, show them, and the web page shows them, and the client can select one, the user, goes back to the use case, and the use case says, hey, I'm done because I've reached my post condition. And my post condition was selecting a customer. So I'm going back and I'm out. Then I've run this use case. So every use case goes through all these layers. So that's what we need to find a way of implementing this stuff in a way that we could use and reuse these use cases over and over again in our applications. So we've implemented this particular pattern, which I'll show you the working of in code. As you'll see, I'll skip all of the text slides because I hate reading text. I'll just rather tell a story. So what we did is we sort of like came up with a mechanism that emulated a use case. So it's a pattern that actually we first started off with an interface. It has a run method because you need to be able to run the use case. And what a use case usually does is first it validates its preconditions. So are the preconditions met? Right. If so, then I can start. So this is the code you will actually see here. This is the actual code we use for that. And then you will see that there's also ways of finalizing the use case. So there's a method called finish and OK and cancel. But actually the OK and the cancel just call on the finish one. So, and by calling the finish method on a use case, we consider it done. So the use case execution ends. And actually by doing so, we create a pretty good mapping between the actual requirements and the actual code. And actually we had testers try to read both of them, testers that actually could read some code, and they say, hey, this looks pretty similar. So that's good. So I'll show you how it works. I'll skip this one as well, because it's the same as I will show in the next slide. So here's my use case diagram. And here's my use case called Manage Office. And the Manage Office use case is a use case to maintain data for one particular office. So I'll start it up from the menu. Actually, it's by walking this arrow that you start up from the menu. So you'll see here that there's a constructor that says Task Manager Run Titan, which is the name of the application we're building, called Manage Office. So it starts the use case. So what it actually does is it will trigger a method on the use case, which is called start. Actually, there's two more called in it, but and this method says, well, if there's some parameters that go in here, one of them might be an office. So if so, we're good. So we don't need to select an office. So it says, okay, this set on the property and activate the view. So activate the web page for this particular office. But if there's no office coming into the method, then we will start another task. This is actually an extension method that covers taskmanager.run. And we'll start off selecting an office. So what we'll do here is trigger another smart use case. So the task manager actually creates the other use case, and it also has a start method. Of course, because all of these smart use cases have a start method. And we create an office search object and some office types, and we activate the view. So after activating the view, we see this. This is actually a layout from about, I don't know, a year ago. It looks totally different now. So this is the page that comes up. This is typically a search page. Like I can add in some, I can type in some criteria, press search, and out comes a list of these different offices that actually meet the criteria. So I can select one. When I select one, there's another piece of code that goes off. It's actually the selected index change for this grid, and it actually says go back to the task, because the view knows the task, and trigger the method select office with this particular office. So I go back to my select office task, and there should be some code in here that says, okay, this is select office, I got an office, and I'm done. So I trigger my OK method, saying that this particular use case, this one, is now done functioning, and it has selected an office. So now we go back to the manage office, and it comes back. There's a continue method for it. Actually, we changed the frameworks that we used over time a bit, that there's different continue methods for coming back from different use cases. So there's no if and switch cases mirror anymore in this code. But actually it says, if I come back from select office, and it went okay, then okay, my main office is this, and in the end I will activate the view. And then the view for this particular use case will show up, which is something like this. Well, it is actually this. So now I can change some stuff, and I can press the save button, and it will try to persist everything that's on the screen to the domain object, and go to the task go back to the task will save the office, and I'm done. And then this use case is done too. And actually, if you look at the diagram, we would have walked through this one, go here, go back to this one, and now we're out, we're done. That's sort of like what we've seen in this particular piece of code. So this is the way that we implement these smart use cases. And I still have 5 minutes or something. So I'll try to explain the last piece, because it's an interesting piece as well. We use a pattern that I explained this morning. Has anybody of you seen my talk this morning? Oh, that's a few. So you'll be able to explain this pattern to the other ones now, won't you? Just kidding. So we use a static facade, which we call, in this case, it's the task manager, that actually uses a piece of dependency injection to get through the actual implementation that executes the tasks. So the task manager doesn't do anything. And to be able to use dependency injection, we created the interface, use case in the domain layer. So we created actually some extensions and a test manager that allowed us to write unit tests for them. And the funny thing is, having used this manager provider pattern, we were able to set up our test environment differently than our usually production environment, because in the test environment, there's no such thing as a web page or a session object or whatever you have. So you need to plug in different things into your task provider, into your view provider. So usually, if you see the code activate view, it will trigger the view manager saying, hey, please go and activate my view. But in the test environment, or in the normal environment, that would set up an HTTP request and go back and get the page and stuff like that. And but in the test environment, the actual provider for views just says, hey, I'm fine, you just triggered this view and it's okay. So I can actually check that if I run the use case in the test environment. So outcomes code like this. I create a contact. This is actually a test method. I'm going to initiate the task, which is actually, you can't see that because there's some text button, but it's a generic test unit class. So here's my task that I want to test. I test the init method or the start method. And if so, if I pass in a contact, it will say that the view will be activated. And we can say that because we plugged in the other view provider, the test view provider, that says, hey, view is activated. So this is a way also to test this stuff. And the good thing about it is I'm nearly through the slides, so I'll take 1 minute more of your time if you allow me to. And it also tests like methods that run through from the use case down to the domain layer. So for saving the contact, for instance, it checks whether validation succeeded. So validation manager also is plugged in, and whether that's not empty, stuff like that. So you can actually test a whole lot of your code in your application using this. So rounding up, actually, in a lot of projects, I think requirements are largely underestimated. Either they're written down in very thick Word documents, or they're written down in very big use cases, or they're written down in sometimes too lightweight user stories. So this use case technique, smart use case technique, is really in between too lightweight and too heavy, which makes it all right for a lot of projects. Probably not for all projects, but for a lot of projects. And the good thing is, if you've already modeled them and standardized them using the stereotypes, you will be able to build them yourselves as well. So there's direct traceability between business requirements, at first going to processes, going to use cases, smart use cases, into your code. Actually, we also generate a lot of code for it too. And also into your tests and into your unit tests. So it actually gives you a full round experience from business requirements to tested code, being able also to put it into maintainability. So that's sort of all that I wanted to tell. I hope the speed of this talk wasn't too high, because it's a longer talk that I try to comprise into 3/4 of an hour. Thank you for having me here again. Again, this is the website that you will find most of the stuff about these smart use cases on. This is my Twitter account. It's the best way of asking me questions. You will probably get an easy and right away response. Okay, thank you, and have a good afternoon.